Good afternoon, dear participants of the conference. Today, the authors present the paper called Processing Pipeline for Data Mining of the Primary Orbits of the Solar System Objects using the Väisälä method. The potential asteroid-comet hazard becomes a problem in the modern world. Therefore, it's necessary to develop a computational algorithm for determining the primary orbits for better discovery of the different solar system objects. For such algorithm, we selected a combination of the classic Väisälä method and processing pipeline in the Kalytek software. This algorithm makes it possible to estimate the geocentric rectangular coordinates of the investigated object, as well as to find the Keplerian elements of the object's orbit. On this slide, you can see a schema of the developed computational algorithm for determining the primary orbits and discovery of asteroids using the Väisälä method. In general, the developed algorithm consists of four main steps: data calibration, orbit determination, Väisälä method, and Kalytek software. The data calibration step aims to remove imperfections, making the data more suitable for scientific analysis and interpretation. In our case, we used dark and bias subtracting and flat fielding dividing in the various sequences. In this slide, you can see the equations for the orbit determination as well as topocentric directions to the investigated astronomical object. The next step is an applying of the classic Väisälä method. It allows us determining the geocentric velocity components in assumption that we have two observations of an object, at least two observations. So, in this case, we need to have continuously observations of the same objects of solar system. The whole algorithm includes the usage of the Kalytek software for performing the intraframe and interframe image processing. The high-level processing pipeline of the Kalytek software is presented in this slide. A list of the main features of the Kalytek software is described here: calibration, cosmetic correction, brightness equalization, background alignment as a part of the intra-frame image processing and is performed in automated mode. The detection of the different moving objects is a part of the inter-frame image processing. The Kalytek software is installed at the variety of telescopes at the different observatories in Ukraine and around the world. In this slide, you can see some observational instruments on which we performed testing of the developed algorithm. AZT-8 telescope at the Kyiv Comet Station and OMT-800 telescope at the Odessa Mayaki Observatory. Both such observatories have the official identifier from the Minor Planet Center from Harvard, called MPC code. Also, you can see the technical characteristics of these telescopes: the identifier of cameras, field of view, image scale, focus ratio, and size of main mirrors of these telescopes. Results of the observations are presented in the next slides. As a result of our observations, we firstly reported a few new asteroids, as well as a few last small bodies of the solar system we found. All these observations and discovered asteroids have a new MPC circular and identifier. The developed computational algorithm is realized as a processing pipeline, which includes combination of the Kalytek software pipeline and the specially developed tool with implementation of the Väisälä method. Such a tool was developed as a console application using the Delphi programming language. The developed computational algorithm was tested in practice and shows a good results. With its help, the several new asteroids were firstly reported, as well as the last small bodies of the solar systems were found on the Odessa Mayaka Observatory and the Kiev Comet Station. Thank you for your attention.